Hello and welcome. The topic of this video is about the data scale. Below is an example from the Fox News that was created in 2012. So if you watch the Fox TV news, you see some figure like this. The two bars are significantly different. So if the Bush tax cut expires, we will see a huge increase in our tax rate. But is that true? We have been talking about fake news all the time. This is the fake news. If you're using the absolute number as shown in the right side, there's not much differences, at least not significantly increasing. So a design principle for visualization is to always maintain your data integrity. So when should we apply the different scale of data? It all depends on your context and how you interpret the data. We may apply different scales. The first is the linear scale. The visual spacing between each of the data points is the same regardless where the data points are on the axis. The second scale you may adopt is the logarithm scale, which condenses the distance between each of the data points when the value of the data points increase. For example, if your data value increases exponentially against another, you will quickly run out of space to illustrate the trend. By taking the logarithm of large value, we may avoid the issue. A third scale could be the percentage one. A percentage scale is usually linear, but when it is used to represent part of the whole data, its maximum is 100%. Let's use the following example to illustrate the scale for comparison. It's about decomposing the Facebook offering visualization. Well, you see here, the first plot given here is the tech IPO values, and this is linearly plotted with the absolute value. You may observe some great companies like the Apple, the Microsoft, and Google. When applied the first launch IPO, when Apple first launched its IPO in 1980s, the value is about 3.4 billion. Then for Microsoft, the IPO value is about 1.1 billion in 1986. How about Google? Google launched its IPO in 2004, and the value here is about $28 billion. Where is Facebook? Can you recall the IPO value for Facebook? In fact, we cannot plot the Facebook in the first plot, as its value is far beyond the given range. Let's move to the second plot, where we have significantly shrunk the vertical axis and allowing a much larger range. Wow, this is where the Facebook locates. The IPO value is about $100 billion. In this plot, can you still compare Facebook with many other tech companies like Google, Apple, and Microsoft? Basically, you only see Facebook and the rest. So this plot is not very meaningful for comparison. The underlying reason is our inflation over years. So using the absolute value is not appropriate because the valuation increases exponentially over time. In that case, we should switch to a different scale. Let's try for the logarithm scale. Now it makes much more sense to compare. Okay, thanks for watching and enjoy learning.